sixth lesson to teach today because I'm doing this all on Monday. But you should have your notes from yesterday. Flip them over to the back side of the paper. So you should have these notes from yesterday. Flip your paper over, and it should be on March 24th. So yesterday we did volume of prisms and cylinders. Today we're going to do volumes of pyramids and of cones, which are similar to what we did yesterday, but they have a little bit of different formulas. I'm going to give you 20, 30 seconds to get these notes out. Got 10 seconds. All right, so the volume of a pyramid, the formula is down here. It's 1/3 B area of base times height. So let's write again, B equals area of base. So the volume is 1/3 area of base times the height. Just writing a little bit bigger. Similarly, for a cone, you've got the volume equals 1/3 area of the base times the height. Or the area of the base can be written as pi r squared because the base of a cone is a circle. So I've got 1/3 pi r squared, right, area of the base times the height. Again, already written down on your paper. I'm just writing it a little bit bigger. Remember, this height is the height of the cone or the height of the pyramid. Notice that they're similar to a prism, only part of it, a pyramid is essentially a prism where part of it's been taken out. 2/3 of it has been taken out. All right, so let's look at example 1. So when I look at example 1 here, this is not a square. It is a right triangle. So when I'm looking at the area of the base, I'm looking at a triangle, which is 1/2 little b, which is the base, times the height. Notice this is little b because it's the base of the triangle. This is big B. This is the area of the base of the pyramid. So I've got 1/2 4 times 6. 4 times 6 is 24. Half of 24 is 12. Now, I look at the volume, and I've got 1/3 B times the height of the pyramid. So volume equals 1/3 area of the base, which is 12, times the height of the pyramid, which it tells me is 9. So 12 times 9 is 108. If I multiply that by 1/3, I get 36. Remember, I have to use the unit squared, which means I have meters cubed. And the count is back to visit us. I have to come over here. Hi. I'm recording lessons right now, though, for the rest of the week.
You talk to yourself?
Yes. So if you'd like to say, it's recording. So if you'd like to say hello to your fourth block.
Yeah.
You guys speaking, you can speak from right here. Because it's recording. So watch. Okay. So for a cone, you're still doing the area of the base times the height. So the area of the base is going to be pi r squared. No, Franklin can't come in. Okay. So I have pi times the radius, which is 2.2 squared. I get the area of the base is 15.2. All right, you can say hi to your class.
What's up, y'all? What it do? It's County. How y'all?
Okay, go. Take Franklin with you.
And we gonna thug it.
Bye.
Hey.
She's at practice. All right, so we got the area of the base is 15.2. The volume of my cone is 1/3 area of the base times the height. Can you do me a favor and please close my door? Thank you. The area of the base we got was 15.2. The height of this cone is 4.5. There's a little bit of decimal. So the height of this cone is 4.5. So when I plug all this into my calculator, I'm going to put 1 divided by 3 in parentheses. 15.2 times 4.5. So when I plug it into my calculator, it should look like this. So the 1 divided by 3 has to be in parentheses. And then I can hit enter. And I get volume equals 22.8 centimeters cubed, because I'm talking about volume. Notice this cone was slanted, but it gave us the vertical height. So it gave us the height this way, not the height that way. Same thing goes for example 3. It's very similar to example 2. Oh, it's not, because we don't have the radius. So we have to find r first. But notice we have a right triangle here. And we know that this side is 16, and then this degree right here is 65. So what trig ratio uses opposite over adjacent? Tangent. So I have the tangent of 65 equals 16 over r. Opposite over adjacent. I cross multiply. I get r equals, or r times the tangent of 65 is equal to 16. Divide by the tangent of 65 on both sides. Sorry, I've run out of room. Make sure your calculator is in degrees. And I'm going to round up to 7.5 feet. So my radius is 7.5. Now I can go back to what I did for this cone over here. Find the area of the base and then multiply it by the height of the cone. So the area of the base is going to be pi times the radius squared. My radius is 7.5. 7.5 squared times pi gives me 176.71. Got 1/3 base, area of the base times the height. 1/3, 176.71 times the height of the cone, which is 16. Plug all that into my calculator. And I get 942.45 feet cubed. Forgive me if any of my calculations are wrong. I'm doing this all by myself and getting distracted. Again, if you miss anything, these are all going to be online via the website. All right, so this is what you're doing today. So you're doing volume of pyramids and cones today. Tomorrow, but I'm including it in this video now, is spheres, both the surface area and the volume. So let's look at volume first because that's what we've been doing so far, and then surface area is not much more difficult. So the volume of the sphere is 4/3, I'm going to write a little bigger, 4/3 pi r cubed, pi r to the third power. So all you need to know is the radius. When we look at the surface, so that's volume. When we look at the surface area of a sphere, that's how much, so volume is how much air we could fit into a ball. The surface area is how much leather it would take to actually create the ball. So like the outside or wrapping the ball. So how much paper it would take to wrap the ball. So that surface area is 4 pi r squared. Notice we're talking about area, so we've got r squared as opposed to r cubed. Okay, so let's look at an example of both surface area and volume, because that's what you'll do tomorrow. So find its volume, and then we'll find its surface area. So a soccer ball has a diameter, a soccer ball has a diameter of 9 inches. So if its diameter is 9 inches, we can't use the diameter to find the volume or the surface area. We have to find the radius. So the radius equals 9 divided by 2. The diameter divided by 2, which is 4.5. So that's equal to r. Now that we have r, we can do both the volume and the surface area. So let's do volume first. So we've got 4/3 times pi times 4.5 to the third power. And we're going to plug all of that into the calculator. So you're going to do parentheses 4 divided by 3. You can put pi in parentheses if you want, and then parentheses 4.5 to the third power. So it should look like this. And then I can hit enter, and I get 381.7 inches cubed. So that means I could fill the ball with 381 cubic inches of air. So that's how much it takes to fill the ball. The surface area is going to be 4 times pi r squared, 4 times pi times 4.5 squared. So 4 times pi, 4.5 squared. This is how I put it into my calculator because there's no decimals or fractions. Sorry, there's no fractions. I don't need to put the pi or 4 in parentheses. So 4 pi, 4.5 squared. That gives me 254.47 inches squared because we're talking about surface area. Questions? If you have questions, ask Mr. Macklin. Fine. Figure it out on your own. All right, so let's look at this last example here because we've now taken a cylinder and we've essentially cut out half of a circle. So I need to find the volume of both of these things and then subtract them from each other. So let's find the area of the cylinder first. Volume of the cylinder. Volume of the cylinder. So that's C, volume of the cylinder. I've got area of the base, which is pi r squared. So I've got pi r squared times the height of the cylinder. So I've got pi times 2 squared times 2. That gives me pi times 4 times 2 which gives me 25.13 inches cubed. So that's the volume of the cylinder. Now I need to find the volume of the sphere, and then we'll come back to that. So the volume of the sphere is 4/3 pi r cubed. My radius of the sphere is still 2 to the 3rd power. So I have 4/3 pi and then 2 to the 3rd power, which gives me about 33.51. So that's the volume of the sphere. But it's not a full circle. Notice this here, a full sphere. This here would be a full sphere if it went outside. But it's only half of it. So I have to divide this by 2. It's only half, so it's like I took it's as if I took this right here, which is a cylinder, and then I cut out, like a scoop out. Or think about when you take ice cream out, a scoop out of ice cream. So if I'm taking it out, that means I'm subtracting it from the cylinder. So over here, this is a different problem. My total volume is going to be this 25.13 minus 16.75. And then I have to have inches cubed. I'll leave that up so you can make sure that you copy it. So this would be the total volume of this section here, minus what was cut out. Again, this will be up on the website. You'll be working today only on pyramids and cones, and then Friday, tomorrow, you'll be doing volume and surface area of spheres. I hope you guys have a wonderful spring break, and that you are being productive so that you don't have any work over spring break and that you can enjoy your time. I will see you guys later.